morning.
Laplace खाता लगते Laplace.
I am not hungry.
No, hungry.
Mesa.
Equation
It's writing later.
It's very busy.
Yes. The love letter is writing.
Oh, my son, your Chinese is very good. Need hungry. 很好。
什么问题？
什么？我不是。我不知道。
你不知道吗？为什么你不知道？
没事，你有多少女朋友？女朋友？一个，两个。
中国人？
No. In your country, you saw me one picture. You was live together with her. Man, you saw me one time. No, not only me, you saw some of people.
We wanna see your girlfriend. I'm single.
No, don't kid it.
I'm single.
Listen, Samimu, he said me, he will marry in Africa. He like. So please manage for him. Please.
I'm getting one. Really? One African. Really?
Anyone sleep this floor?
Yes, Doctor, it's dirty.
Very dirty.
Yes.
Maybe no one.
Yes,
Raji, before, after this vacation, I will go office, take this one, and I will clean it, okay?
Oh,
I will.
Hand how? Happy hand how?
excellent, great.
Yes, great.
Monitor is monitor.
Monitor, yes.
Yes.
Raji, this is our classroom. This is, we learn in here. If we don't care, we don't take care of this.
It's our duty.
Who take care of this? I will manage and clean this one. Samir, brother, Laji, this is some of 20 photos, so I can give him, I can give him, he will sell this, maybe he will get 1 or 2 yuan to sell this one. Are you happy, man?
No.
Why?
I'm not happy.
Why you are not happy?
Because I am so hungry, Rafi. Voila.
Laji, after 1 year, কি করে? After 1 year, কি করে? After 1 year.
After 1 year?
After 1 year, Shami move, he will get married.
No, no.
사다 누팡에 소우
Your girlfriend in this what?
No, Rafi.
Bangladesh.
After my graduation, Rafi.
I told you about you.
When your girlfriend and wife?
My
You have a girlfriend, Rafi.
No.
Beautiful girlfriend.
no.
Meant to marry. Oh, let's begin the class. And now it is 2020. Now we have this class. And in this class, we also study the Laplace transform solution of linear differential equation. Now, this is the framework of why or of how we use this Laplace transform solution. Now, here for the differential equation is also the mathematical model for control system. Let's say you want to design or you want to design the control system, we build differential equation. And for this equation, it is not easy to find the root of it. Then the Laplace transform is used to convert the differential equation to algebra equation. Now, the differential equation we have no method or have no ways to solve it. But for this algebraic equation, we can solve it with non-equal. Now then, here we can get this mirror function. This is also the solution of algebra equation of algebra. And then we use the inverse Laplace transform. We can get this orange function. The orange function is also the solution of differential equation. This is why we use the Laplace transform, because we cannot solve this equation. The Laplace transform helps us to convert differential equation to algebra equation. And the algebra equation's root can be got easily. And then we use the inverse Laplace transform and then get this orange function. That is the root of differential equation. We cannot solve this differential equation. This will say we cannot give this root of the differential equation directly. We cannot go this step directly, but we can only along this way to this root. So this is the use of Laplace transform. Okay. Now, for the Laplace transform, one of the most powerful tools for computer system analysis and design is the transform function. The first is important. The second, for a single in, single out system with input ut and output yt, the transfer function is defined as zero initial conditions. Laplace transform of the input-output relation of a system. Now, you can see, this is the use of the Laplace function. Here we can see this is the transfer function. The transfer function is the Laplace terms of yt to the Laplace transform of ut. Now where ut is the input and yt is the output. And this input, the Laplace transform of input now is written as big US. And the Laplace transform of yt, it is also output, is written as big YS. You can see. Now, where S is equal to sigma plus I omega. This is the complex plane on the complex plane. Now, we should remember this transfer function is defined as the Laplace transform of output to the Laplace transform of input. This is the definition of transfer function. The transfer function. It is equal to, we often write u, big U is. Now, it also shows the satisfies the zero initial condition. Zero initial condition. Zero. 这个 initial condition.
This is the complex.
Yes, complex plate. This H equal to C plus I omega. This is the S plane. For the S plane, the real X are. And also there is a complex two part. Now, how to get the transfer function? Here is this the steps contain 6 steps to give the steps to get the transfer function. Now, the first step is define the system and its components and identify the input and output of the system. But define the system or also define its components and also identify the input and output of the system. It to say we should give this or we should find the input and the output of the system. The second, we should formulate the mathematical model and list the necessary assumptions. It is so build a mathematical model for the computation and we should give some assumptions. And the step is write the differential equation describing the system. Write this differential equation. The differential equation is built is also the mathematical model. This model describes this system, also describes the relation of input and output. Now, the fourth step is linearize the differential equation. We show that maybe the differential equation for the third step, the differential equation may be nonlinear. So we should make this the differential equation is nonlinear. For the nonlinear differential equation, we should make it linear. So we shall linearize the differential equation. The fifth steps is take Laplace transform with zero initial condition. So this step is very important. Zero initial condition. What's the zero? Initial condition. Would you like to me? I have started the day yesterday, the day before yesterday.
Zero initial condition.
What's this zero initial condition?
This position.
Number 8.
This one. Zero initial condition.
Oh no, look this. Now, this is the transfer of derivatives. And if f0 equal to the first derivative f0 equal to f n minus 1 derivation f0 equal to 0. It is f0 equal to the first derivation and equal to is this zero initial condition. Zero initial condition. If this is equal to 0, we find that the Laplace transform of the nth derivation of ft equal to s power n and times big F s. For this, if f0 equal to the first derivation of f0 and equal to this n plus 1 x derivation f0 equal to 0. Now, all this bird will only, this part is remain. So, we can see the Laplace transform of the s derivation of ft equal to s power n big Fs. So, this is very simple. This is very useful for us to solve differential equation. So, this condition is very important for this class, for this course. So we should remember all with this class. Then that we should determine the ratio output on the input, which is called this transfer function. Then this determine this ratio. The ratio is this Laplace transform of yt. It is also output. And to Laplace transform of ut, where ut is also the input. It can write as big S, the ratio of big S to us. So this is the steps how to determine this transfer function. It contains 6 steps. Now, here this is a linear time inverter system. This system is defined by the following equation, where n is not more than m for a physically reliable system. Taking Laplace transform of this equation with 0 initial condition. Now we find y0 is 0. The first derivative y0 is 0. Now it is also the nth derivation. How to give this Laplace transform of this equation? How to give it? Would you like to do fetch on your exercise book?
Page. Page.
What?
Page number.
Maybe not on this book. Which book? We cannot find it. Not according to this order of this book. So that transform. This is very important, but it not have introduced in the book. Okay. Now first your now here is this the Laplace transform of this equation, the differential equation. Now I should close this PPT. Okay.
어떤 범위를 우리가 이런 범위를 우리가
मुझे ज़्यादा और केवली बुरी नहीं है तो भी मैं उसका बात करूँगी बुरी ज़्यादा और वो पहले ज़्यादा बुरी और वो पहले आते तो भी सॉफ्ट हो रहा कितनी कोई चाहिए तो और कितनी होना चाहिए चलो बीसी तुझे एवढा बीसी माने की करतो
Next is the nth order differential equation yn plus an plus 1 by 3. And 0 1 equal to bm the nth. We will here this is the nth order, but for this input use the m word, mth word plus Now, first, we should use the Laplace transform to convert the differential equation to algebra equation. Now, we use the Laplace transform for the right part of the equation. Now, here equal to what?
YS
I remember the equation I had just told you.
M greater than equal n greater than equal m.
Is Laplace transform of s this y in t equal to what? S in ys minus y0 y0 s y factor 1 0 minus s in
Y n minus 1.
if y0 equal to y factor 1 0 equal to h order n plus 1 order 0 equal to 0. Now then this plus this equation is true. Then by this Laplace transform we can write this Laplace transform of this differential equation. Now for the Laplace transform for the right of this equation, we can get this Laplace transform is s n power n and y. This is big y is plus a n minus 1 big s power n minus 1 and y is minus and a zero y is. This is the right of this differential equations Laplace transform. Now for the for this is the the right of the equation. The right of the equation. Now, we can also write it same is Bm s power m and us, big us, plus Bm minus 1 s power m minus 1 and us and plus B0 big US Do you have any problem with this second equation?
Just as Laplace.
Let's use the Laplace equation and also the initial condition satisfied. Let's see here. Y is this is what? And also
US.
this is US. And we should remember this transfer function. G is Y is the ratio of Y to US. So for this equation, we should put forward this Y is, and this is Sm plus Am minus 1 is power Sm 1 plus and plus A0. That's A0. And it is equal to, it also US and Bm s power m plus Bm minus 1 s m minus 1 plus Bm B0. Now, and then we can get this transfer function of this computation. This is ds equal to ys to us. Now equal to what? Would you like to do to me? This is equal to what?
Oh. Logic.
What?
YS, Bm, Sm, Bm minus 1 is
Would you like to write on the blackboard?
me.
Yes. Okay, please.
Please write on the blackboard.
Okay, good. Yes. The basic maybe not. This is no need for this. Yes.
Tashi. Oh, really?
Okay.
Can I explain it? Can I explain it?
Okay.
Yes, you are allowed.
এদিকে করো না দেখতে তোমার পাঁচটা ওইদিকে সরিয়ে দাও
This is our equation g is equal to ys by us. So we know this that.
এটা কি ফর্মুলা নাকি it's formula
Yes, is the formula.
okay
You know this one. G is equals slope. This gs. S is slope. And us. And ys. So you know that this is slope. G is equal to ys by us.
yes
This equation come from there.
Now let's discuss it.
Yes.
Continue.
continue
Yes. How to
Yes. For this y, we know this. I will take the letter.
বাংলায় দেখো উপরেরটা কি আসলে যে ম্যাথ কোনটা আইডিয়া
Put ki maro bole boli. Edi record hai.
বাবা হাসো কি মেশার করতে
So this is the y function, y to the power n plus a minus 1, y power n minus 1, ay. To be discrete.
ভাই আমি ম্যাথ কোনটা দিতে এটা বলি না প্রথমে কোনটা দিতে
So I transfer for this Laplace function. So I find the Laplace differentiation. So I find this s power n
ব্রো
y.
আসলে সেকেন্ড লাইনটা আমি বুঝিনি
What?
yes
This way? This way?
yes yes
This is our function. We just give it to in this Laplace. This is Laplace. So we find this s power n and s power n and y
সূত্র
s.
নাকি
Hmm?
সূত্র হইছে
Yes.
ওকে
Okay. What is Laplace? You think this is mean?
মিল
Laplace. How about Laplace?
yes
Okay. You think this is milk? If you were to milk to dough, how many times you need? How much hours? Like one day? One day?
yes
You have a milk. You have a milk. You have you have a one bottle of milk.
yes
You need a dough. So you need one day to make milk from this dough. Okay? But you don't have enough time.
yes
You want to make it 1 hour, 2 hours. Okay? So you have to use some hard like lemon, orange, lemon. So this orange, this work here to make you this dough is early. So this orange and lemon is like Laplace. Okay. So this is S is like Laplace.
yes okay after that
This is the property G is equal to ys by us. So I write this one. I just now okay. ys over we have to find ys over us. I just put this YS in this denominator. This is our numerator, this is our denominator. So I just put this YS in denominator position. So here we have dm is to the power m plus dA m minus 1 is to the power m minus 1 and d0. I just put there is a US in this denominator. Do you understand? This is it. So and this YS multiplied Sn is to the power n plus n minus 1 is to the power n minus 1 plus n1. So I just put this one in this denominator.
This is the final result.
Okay. Now let's continue. There is fraction. The control function is a fraction. And for this numerator, this order is n. And for this denominator, the times is n.
Yes.
So we can divide this numerator and denominator. That is this product of first order fraction. What do you mean? Here, for example, for this x squared plus 3x plus 2. Now, for this second polynomial equation, we can write this x plus 1 and then times x plus 2. So, this is first order. This is the first order. Every one is first order.
Yeah, this is the middle term.
So, this is what you can write is first order. Now, maybe you can write as now S plus C1 and times S plus C2, then S plus C
M.
yes. For this dominate, it can write as S plus P1 and times S plus P2 and times S plus Pn. Now it also can write as this K and this pi I from 1 to n. Here is S plus Ji and divided by K pi J from 1 to n. Here S plus Pj. Now we should remember what's the name of K, Ji and Pj. What's the name? We call what it? Now here K is called the gain of this complex system. The gain in Chinese is 真义 gain of the complex system. And this Ji, if we remember, if this S equal to minus Ji and this part equal to 0, so it is the code of 0 of the system, the 0 of the system, 0 of the system. Ji and the Pj. What's the Pj? The Pj is called the pulse of the system. This Ji is called system. And this Pj. This Pj we call it is poles of the total system. So here called pole 0. This is called the gain of the total system, or the name of this system. Now here n, where the n is also order of the system, the order of the system. Here the n. N we call it is order of the system. Order. The system is in order. Is order for the system. And maybe we can see here if this P1, we separate P1 equal to P2 equal to PL equal to 0. Equal to 0, then from P L minus 1 to Pm is not 0. Then this part can write as SL, because this P1, P2, PL equal to 0. So it is L. And then here is S plus PL plus 1. And S plus PL plus 2. And SPL. Here, this L we call it the type of the system. Type of the system. This is the definition or the terminology of the system. Now, here is this terminology of the computer system. Would you like to revert it and you can remember the terminology? Okay.
Vale, puedes dejarlo o algo. Ponte así. Mi mamá está bien.
So, simple.
Sim?
Simple.
Que eu tô pegando.
Simple.
चौबीस यदि खेला 3 दिन में 23 कम रहेगा तुमने फेसबुक सब आना तुझे भी किधर इंटरनेट सब किसी तो लगा होगा सारा दिन इमो तो इमो ये इमो तो कम होगा हम तो जाएगा प्रॉक्सी का हम तो इमो से जाएगा प्रॉक्सी खाला ही तो तब আর তো ভালো বুদ্ধি আছে ওটা করবি তো এই যে নিচে কয়লা দিয়ে আগুন জ্বলে এই যে নিজের
Okay, if you have no critique, we continue.
Yes. অর্থ গায়ে কোনো ই নেই অর্থে গায়ে কিংবা আমরা তৈরি ওটা মরে গেছে আমাদের মাছের গুস্ত খাওয়াই তো দুপুরে খাচ্ছে মধ্যে বাকি আছে নাকে
Now, the character of transfer function. The transfer function of a system is a mathematical model. So, the transfer function is this the most important mathematical model to start control system or for this automatic control system. It is an operational method of expressing the differential equation that relates the output variable to the input variable. Yes, it is brings this output variable and the input variable. Transfer function cannot provide any information concerning the physical structure of the system. Transfer function of different systems can be identical. That's to say, different quantum systems, different physical structures of the system, their transfer function may be the same. Yes. For the electrical quantum system and this mathematical quantum system, maybe their transfer function is the same. So, the transfer function cannot provide any information concerning this physical structure of the system. Okay. We should have a rest.
করবি রাত্রে সিরিয়াস কিন্তু নাহলে কিন্তু আমার ক্যান্টিন যে খাবার কেনা লাগবে না ওই যে ধরো তো বললাম রুটি আর আমার যারা মুরগি আছে তারা কিছুই নেই মুরগি তোর সব গোস্ত আর কি নাটি মাটি নেই মুরগি কাটা মাংস রুটি বানালে আটা আমার কাছে আছে তো আমি তো এখন আমার অনেক মানে ভিডিও প্রোগ্রামটা করছি ওগুলো দিয়ে দেখি আমার দেরি বুঝছেন তা আমি সাধারণত আমার রুমে যাবি 30টা খুলবি আমি আমার রুমমেটটা করে দিতেছি একটা দিয়ে দিবি ওনে এক প্যাকেটে তোর 1 কেজি 800 গ্রাম খায় তো যতটা তোকে লাগে লয়ে তো বাড়িটা কেজি 1 কেজি মানে তো 1.5 কেজির উপরে থাকে এক প্যাকেটে 1.5 কেজি কি খেতে পারবো থাকবে না আমার রুটি হয়তো একটা রুটি খেতে পারবো না রাস্তা নাইলে একটু বিরিয়ানি করবো মাংসটা তো ওই বেটাবড়ি কি মাংসটা ওই কি মাংসটা একটু শক্ত শক্ত মানে মুরগি না চাল তো দিয়ে দিই না ওই চাল দিই তো সেদিন ইয়ে করে দিতে ওই চাল দিয়ে আমার কাছে মশলা আছে বিরিয়ানি করো কিন্তু আমি তো করে চাল দিতে না আরো আর দিন দিয়ে করে পারবো তুমি দেখে দিন যত মাংস তারাই খেয়েছি মাংসটা খেলে টেস্ট দিচ্ছি থাক আমি করে দিতেছি কিন্তু এটা লোক রুটি খেলে আমার পেট হয় না ভালো লাগে হলে ঘরে খারাপ হয়ে থাকি রুটি খেলে কি মানে আমার মন আনন্দ লাগে সেটা আমি জানি মন আনন্দ খাইছি